Server corridors remain perfectly aligned. Cold air moves between vertical racks. Blue indicator lights pulse in steady intervals. Cooling systems regulate temperature drift. Monitoring software records fluctuations smaller than 1 degree. A grid of machines processes incoming packets. Packets arrive without pattern. Within seconds, the flow becomes structured. Unsorted signals enter the system. Ordered streams leave it. Across the corridor, another rack cluster performs the same motion. Detection, sorting, alignment. The sequence repeats. In a warehouse several thousand kilometers away, belts carry identical parcels through automated junctions. Packages arrive with inconsistent spacing. Sensors measure the distance between objects. Moments later, the gaps disappear. Every package moves in synchronized intervals. A routing algorithm directs each object toward different gates. Conveyor paths intersect, separate, and rejoin again. No interruptions appear. The entire floor maintains geometric motion. In a traffic coordination center, a digital city map fills the wall display. Hundreds of intersections appear as illuminated nodes. Vehicle detection sensors transmit constant updates. Signal controllers adjust timing cycles. Red signals pause vehicles. Green signals release them. At first, the flow appears irregular. Several cycles later, movement stabilizes. Vehicles begin traveling in synchronized waves. A grid forms across the entire map. Inside an automated inspection facility, a line of identical components advances toward scanning arrays. Each object pauses beneath a sensor frame. Light sweeps across the surface. Microscopic measurements enter the system. Irregular readings appear briefly in the stream. Filtering software isolates them immediately. The remaining signals settle into uniform patterns. Production continues. Across global networks, data centers exchange monitoring signals. Logs accumulate continuously. Error messages appear in scattered intervals. Analysis software reorganizes the records into structured timelines. Clusters of anomalies become isolated blocks. Remaining entries align into predictable sequences. Dashboards display stable operational states. In robotic coordination systems, multiple machines operate inside enclosed industrial zones. Each robot repeats programmed motion cycles. Arms extend. Objects shift position. Sensors measure location variance between machines. When distance thresholds approach limits, movement speed adjusts automatically. Paths reorganize continuously. Robots never collide. Their trajectories remain evenly spaced. Monitoring software records these environments simultaneously. Warehouse routing, traffic grids, inspection scanners, robot coordination systems, data center orchestration, different industries, different machines. The same operational signature appears. Unstable input signals arrive first. Moments later, the environment restructures itself. Irregular spacing becomes uniform spacing. Unsorted signals become structured streams. Random motion becomes synchronized motion. Across thousands of machines, one operational preference remains visible. Systems do not search for intelligence. They search for order. Intelligence appears only after order stabilizes. In every monitored environment, the earliest system activity follows identical patterns. Sorting layers activate. Alignment protocols adjust spacing. Detection pipelines isolate irregular signals. Control software maintains stable intervals. Monitoring systems begin recording higher-order classifications. Optimization routines begin calculating adjustments. Prediction modules begin operating. Across warehouses, data centers, inspection facilities, traffic networks, and robotic production floors, the same structural behavior repeats. Signals enter in unstable form. Systems reorganize them into structured flow. Machines maintain spacing. Algorithms maintain sequence. The environment stabilizes. Operations continue. The logs show no search for intelligence, only the continuous reconstruction of order.